The rotation matrix theorem generalizes rotating images in the coordinate plane to any image besides 90, 270, and 180, which is what we've already discussed. So the rotation matrix theorem says that you can multiply by this general theorem, which would be the cosine of theta and the opposite of the sine of theta, and then sine of theta, cosine of theta. So you can take any angle and use this matrix and multiply it by what you want to move and rotate it at any angle you would like. So if I just ask you for the general 2 by 2 rotation matrix for rotation of 30, then we're just going to go ahead and plug in 30 for all of those. So that would give me cosine of 30, sine of 30, followed by the opposite of the sine of 30 and the cosine of 30. Because this is from the unit circle, you should know exactly what those values are. The cosine of 30 is the square root of 3 over 2, and the sine is a half. The opposite of that is negative a half, and then the square root of 3 over 2. Okay, so that is your answer matrix. Same idea for example B, where we're talking for 45. So the cosine of 45 is the square root of 2 over 2. The sine of 45 is the square root of 2 over 2. The opposite of the sine is negative square root of 2 over 2, and then the cosine is the square root of 2 over 2. Okay, so you're taking the angles you know and plugging them into that theorem. Rotation of 60 then, this time the cosine is a half, and the sine is the square root of 3 over 2. The opposite of that is the negative square root of 3 over 2, and then the cosine, is positive 1/2. Okay, so those are your primary ones, 30, 45, 60. You should be able to do those without too much of a problem. Example D now actually wants us to rotate a point 30 degrees. So first I want to write down the rotation of 30 matrix, which we just wrote down in example A. So that's the square root of 3 over 2, 1/2, negative 1/2, square root of 3 over 2. Okay, this always goes on the left, just like what we've been doing all chapter. And then we multiply it by the point matrix 6, 8. And now we just multiply. Okay, so the hardest part still is doing matrix multiplication. Okay, so you're going to go across by down. So this one I'm going to write out for you. So this is going to be 6 times the square root of 3 over 2 plus negative 1/2 times 8. Okay, if I simplify that, I know 6 divided by 2 is 3, so that gives me 3 square roots of 3 minus 4. Okay, so that's going to be my first value. You cannot put together the square root of 3 and negative 4 because one has a square root and one does not, so that is simplified enough. Okay, now if I move to my second row, I'm going to get a half times 6 plus the square root of 3 over 2 times 8 over 1. Okay, a half times 6 is 3 plus, I'm just going to multiply those fractions across. That would give me 8 square roots of 3 over 2, which is plus 4 square roots of 3. Again, those don't simplify at all, so this is actually my final answer. Okay, so take a look at that math. If you're not sure, just pause it here and just think about how you multiply fractions. Example E wants to take an entire triangle and go around 45 degrees is what that should say, around the origin. So 45 degrees is the first matrix I'm going to write down, which is the square root of 2 over 2, square root of 2 over 2, opposite square root of 2 over 2, positive square root of 2 over 2. Now I want to multiply it by that triangle, so that goes 3, 2, negative 1, and then 5, 6, negative 4. Okay, again, you're going to go across by down, and the hardest part about this is knowing how to multiply matrices. Okay, so across by down. Now, if I write that out, that's going to be 3 times the square root of 2 over 2 plus 5 times negative square root of 2 over 2. Oopsies, I forgot my 2. Okay, that gives me 3 square roots of 2 over 2 minus 5 square roots of 2 over 2. Okay, because those are like terms, I have 3 halves minus 5 halves gives me negative 2 square roots of 2 over 2, which actually becomes negative root of 2. Okay, so my first value here is negative square root of 2. Okay, so again, you can go straight across by putting 3 over 1. That gets me 3 square roots of 2 over 2. Again, you can put 5 over 1. That's 5 square roots of 2 over 2. You can kind of treat your square root of 2 as a variable. So I've got 3 halves minus 5 halves is negative 2 over 2, which simplifies down to negative 1. If I move over to my next column here, that's going to give me 2 times the square root of 2 over 2 plus 6 times negative square roots of 2 over 2. So I can kind of just put that all over 1. So I've got 2 square roots of 2 over 2 plus -6. That's going to be -4 square roots of 2 over 2, which will reduce down to -2 square roots of 2. So -2 square roots of 2. Moving over to my last column here, that's going to be -1 square root of 2 over 2 plus, because negative times a negative is plus 4 square roots of 2 over 2. That gives me a total of 3 square roots of 2 over 2, because I have -1 plus 4 is 3. And then that one will not simplify down at all. So there's my top row. Okay, now I'm just going to erase some of this stuff, and so I've got room so that we can do the second row here. And my computer's being nice and slow this morning. Okay, so moving on to this bottom row. Now I've got square root of 2 over 2 times 3 plus 5 square roots of 2 over 2. Put those together, that'll be 8 square roots of 2 over 2, which will reduce down to 4 square roots of 2. Moving over here to my second column now, I'll have 2 square roots of 2 over 2 plus 6 square roots of 2 over 2. That gives me, again, 8 square roots of 2 over 2, which gives me, again, 4 square roots of 2. And moving to my very last one here, I've got -1 square roots of 2 over 2 minus 4 square roots of 2 over 2. Watch your negatives. -1 minus 4 is -5 square roots of 2 over 2, and that one does not reduce. Okay, if you're having problems with the algebra, just take some notes and then bring those to class tomorrow, okay? But let's try a couple more. So F says take the image of that under a rotation of 135. So just like before, I want to do the rotation of 135 first. And the first is the cosine. Well, the cosine at 135 is negative square roots of 2 over 2. The sine is still positive, so then when I do the opposite sign over here, that's going to give me negative, and then the cosine is still negative. So the only thing that changes here is now I just have some more negatives. Okay, so then I'll multiply that by 4, -6, 4, and then 2, 3, -2. Okay, and this one's going to simplify similar to the last one. Okay, so I'm going to go across by down. That's going to give me -4 square roots of 2 over 2 minus 2 square roots of 2 over 2. That gives me -6 square roots of 2 over 2. So that first one is -3 square roots of 2. Okay, moving over to my second column, that's going to give me 6 square roots of 2 over 2 minus 3 square roots of 2 over 2. 6 minus 3 is 3 square roots of 2 over 2, and that does not reduce. So that will be my final answer there. Moving over to my last column, I'm going to get -4 square roots of 2 over 2 plus 2 square roots of 2 over 2. -4 plus 2 is -2 square roots of 2 over 2, which reduces to just √2. Okay, same idea. Again, we're going to go down here to my second column now and keep the same process. So now I'm down here and I'm by my first row now, or my first column. So I've got 4 square roots of 2 over 2 minus 2 square roots of 2 over 2. 4 minus 2 is 2 square roots of 2 over 2, which reduces just to square root of 2. Going over to my second column, I've got -6 square roots of 2 over 2 plus -3, whoopsies, sorry about that. That should be -3 square roots of 2 over 2. -6 minus 3 is -9 square roots of 2 over 2. That does not reduce, so that one will stay like that. And then moving over to my last column here, I've got 4 square roots of 2 over 2 plus 2 square roots of 2 over 2. 4 plus 2 is 6 square roots of 2 over 2, which reduces to 3 square roots of 2. Okay, again, the hardest part here is the algebra, so just be careful here. Okay, and then my last one will say take this triangle and go over a rotation of -30. Okay, kind of like what we talked about with other rotations, make that positive. So -30 is a positive 330. So the first thing I want to do is I want to write down the matrix for a rotation of 330. The cosine there is the square root of 3 over 2, and the sine is -1/2, which means the opposite of that is +1/2, and then I'll have the square root of 3 over 2. Okay, so then I'll write down my matrix that I'm rotating. Okay, right next to it, always putting the rotation one on the left. Again, we're going to always go across by down. Well, that first one is easy. That first one's just going to get me 0, because I get 0 plus 0. Okay, moving over to my second column, I'm going to get 8 square roots of 3 over 2 plus 0. So that reduces to 4 square roots of 3. Going to my last one, this will be the fun one, 6 square roots of 3 over 2 plus 1/2 times 2 square roots of 3. Okay, well this first chunk will become 3 square roots of 3 plus, I can put 2 square roots of 3 over 1, go straight across, so I get 2 square roots of 3 over 2, which means those cancel. So now I have 3 square roots of 3 plus the square root of 3, which is 4 square roots of 3, because those are like terms. Okay, sounds a little trickier. Just remember, make everything a fraction and go straight across. Okay, going down to my second row then. This first one again is easy. It's going to give me 0. My second column then, going over here to my 8 and my 0, I'll negative 1/2 times 8 plus 0. That's nice. That's negative 4. And then moving on to that last fun column, I've got negative 1/2 times 6 plus the square root of 3 over 2 times 2 square roots of 3. Again, I'm going to put that over 1 to help me out. Negative 1/2 times 6 is negative 3 plus. So on the top there, I have the square root of 3 times 2 times the square root of 3. Well, if you remember, the square root of 3 times the square root of 3 is just 3. And then I've got that over 2, so the negatives cancel. So that's negative 3 plus 3. So this actually gives me 0. Okay, so the general rotation matrix theorem, the hardest part is algebra. Go ahead and try that homework in your homework packet and be ready for the partner quiz tomorrow.